Hello and welcome everyone to this R programming masterclass. Well, this is going to be an exciting video because at this one video, I'm going to cover all the basic ideas of R programming. Well, R is a very popular programming language, especially for statistics and data science. And if you are a complete beginner of R programming, or maybe you already know the basic ideas, but you want to practice all the things organizingly, then this video is perfect for you. Moreover, the topic I'm going to cover in this video is that the operator, vector, matrix, data frame, and then if-else, loop, and function. And of course, initially, I will show you how can you install R and RStudio. Well, before starting this video, I have a very special announcement to share with you. The announcement is that within a few days, we have a live training on R programming. You can watch the whole video and check that whether this training or the way we teach is suitable for you or not. Why we believe this training is better than other online courses or training is that all the classes will be held in Zoom and we can interact with each other. You can ask questions in the class, and we provide all the R course with explanations, and we teach you how can you deal with the real data set and provide all the data set. Also, we show you how can you interpret the data files and provide you everything. That is why we believe this training is better than other courses. And of course, the assignment and quiz will also be there to check how much you can improve your skill. Okay, so if you're interested for this training, please message us, maybe in the Facebook, maybe in the WhatsApp, LinkedIn, Instagram, or check our website www.datasciencera.com. You can check out the description box or in the comment box or any areas where all the informations are also given. So, I would love to tell you that why R programming languages? It's because, first of all, R is completely free and open source programming languages. And then there are a lot of resources are available where you can check out the course with a lot of examples. A lot of PDFs are available for free. And the most important one, there are 10,000 plus free packages are available. For example, you want to fit a model, you will see there is a package. You want to clean the data set, there is a package. For example, here I have some packages named, like there is a universal package named as tdverse. Inside this tdverse, there are also some other packages, like for data manipulation, we use the deployer. For data visualization, we use ggplot2. And for data import, we use readr. Okay, so at last, I would love to let you know that a lot of big companies, like I mentioned here, like Facebook, Google, LinkedIn, also like Twitter, Amazon, a lot of companies hire people who are skilled on R programming, focusing on statistics, on data science. Okay, so let's get started this video with installing R and RStudio. Now to download R and RStudio is very easy. Just search in the Google that download R, okay? You'll be able to see that a website is coming out there. Just click here, download R 4.0.3 version. I'm using Windows, so I'm just clicking the Windows. If you use Mac or any other, you can just select from the appropriate option you have, okay? So let me just select that and the download will automatically start. And you can go to here and just click the download option. And well, in my computer it is already downloaded, so let me just show that from here. Okay, here is the R and here the file is. Now let me just click that. You can see that a new window is coming out, so just start run and then just click yes to go forward. And then you want to check the you want to change the language, you can also do that. Let me say that, I use English, then click OK, and then a new window is coming out. Just click next, and then you can select the appropriate folder where you want to have your R. Okay, just select the location. Then next, Then you can use 32-bit or 62-bit depending, 64-bit depending on what type of Windows are you using. Okay, now just click next, and you can just use the customized setup or you can just use the default setup. So let me select the default one and next, and then again next, and then you can just click next. There is no need to change anything. Okay, now you can see that the installation has started and it will automatically finish within a few seconds or minutes. So after the installation, so let me just cancel that because it's already installed. Okay, let me cancel that and let me open that directly. Here you can see in my computer I have already R 4.0.2. Okay, so let me open this. Okay, and you can see that a new window is coming on. So here it is our R programming. Now here you can start writing your code. Now if I just want to check it that whether it's working or not, let me just click 2 plus 3, and you can see that it is saying 5. Okay, it is saying what? 5. So yeah, it's working, but we will not directly use R for writing our code. There is an interpreter named as RStudio, which has a lot of option, a great interface to write your code. Okay, so now you can download the RStudio. Make sure you remember that at first you need to download R before downloading or installation of RStudio. So to download RStudio, let me go back to Google and ask Google that download RStudio, right? Now you can see that a website is coming out, rstudio.com. Here you will have a lot of resources. Now if you can just check the, okay, here you can just select whichever version you're using, which one is appropriate for you. So I'm selecting the free version of RStudio desktop, and then I'm selecting this one, let's say Windows 10. You can select the Mac or any other version you're using. You can see that the downloaded has started automatically. Let me go back to my downloaded option where I already downloaded that. Now let me open that and try to install that. Okay, it's easy and quite similar like the way we downloaded R, so no need to worry on that. Now just click yes, and then like previously, okay, RStudio is currently running. Okay, in my computer it is currently running. Here you can see that. If you install that already, you can just search here. You can just search here by RStudio. Okay, here you can see in my computer is already installed. Now they're asking me to close that and try to install that again. I hope you can install that by yourself very easily, right? So now after installation, here is our RStudio. You can see that here you have 4 different screens, right? Like this one, this one, this one, and this one. Okay, so 4 screens you have. This screen and this screen is very important because this screen will allow you to write the R code. So all the code you can write in this screen. Okay, and all the output will coming out in this screen. Here you also have different options, like you can import the dataset from here. Here you can see in the environment there are a lot of variables name are coming out, which I used for the couple of days. And also in the history you can check out all the code you used in the last couple of weeks. Okay, and this screen you can just drag it up and down here. All the screen you can drag. Okay, and this screen you have options like files, and whenever you have output in, like for the data visualization, like you have a graph, the graph will show in this screen, not in this. Usual output will come out in this screen. Okay, and you can ask help here also you can download or install different packages from here. Just click install. Now if I click, or if I just search here, let me open that. It is opening and taking a little bit time. Okay, so you can just search the package name and just click install. Let's say I am using ggplot2. Okay, then you can just click install to install your package. You'll show that a little bit later on. And yeah, let me show you one more thing is that here you also have a lot of options, like you can save the file. Make sure whenever you write the code, you save your file. Then you have, like, if you want to check the appearance or just just change the size of the letter you're using. Okay, just go to the tools and then global options. Then in the appearance you will have a lot of options, or the font size. Okay, like if I can use these, I can use clouds, I can use these, I can use these. So you can change the option whatever you want. Just click apply to change that. Okay, just click apply to change that. So I'm not changing that, I'm using this one. So here is a little bit of idea about this R Studio, and we will always use our code on this R Studio. So here you can see a lot of code I already wrote here for this class with a lot of explanations. Okay, like before every single code there is a node by using hash sign. So let's start your R programming journey by writing your first R code. Okay, and to do that, just go to the file and click the new file. You can also just start a new project for that and just click R script. And you can also write in different options, like you can write by using R markdown. Okay, so R script will allow us to write the code and run the code, also save the file anywhere we want. Okay, so always make sure you save your file so that all the codes are available for your practice later on. Okay, so now just click save here and then save anywhere you want at your computer. Okay, so let's say the name of the file is like R basics and just click save. Okay, so now it's done. Now to write the first program of this R programming, just giving a hash sign, let me just write a note. Okay, this note is not something important for our code. Okay, you don't need to run this line. This is not a code, this is just an explanation. Okay, now to write our code, you always use this screen, I have to remember. Okay, and to use this screen, let me write a function named as print. Okay, print and then a first bracket and then give an inverted comma and then just write hello world. You can write whatever you want. Okay, hello world. And to run this code, just click here or click the whole line. Okay, and just click run. Okay, and then you can see in this below screen you got your output. So the output is saying hello world. Okay, now you must be thinking, okay, how is it working? Well, remember here we are using a function named as print. Okay, R has a lot of functions. Print is one built-in function already R know. Okay, so whenever you write something inside the first bracket of print, it will give you the same output on that line. So if you want to line anything else, like maybe you write like, okay, my name is Saif, so then I will get the output my name is Saif. Also, I want to let you know that you can directly use the code here and directly get the output. So if I write here print, let me just write whatever I want. I am Saif. Okay, now if I just click here, just click enter, and then I'm getting the output. Okay, but remember, it's not a smart option to do. Okay, it's always better to write the code here and then just run it in this screen. Okay, so it will help you to customize the code and edit the code as much as you want. Okay, now also I would love to tell you that let me just describe one or two more code by using R like a calculator. Okay, so remember you can use R as your calculator, whatever you want. So let me just use some of the like 12 plus 24. Now if I run this line, you can just click here. Also you can click Control Enter at your keyboard. Okay, if you click Control Enter, here I got the output 36. Okay, now if you want to use the multiplication, you can write 12 into 24 into 26. Okay, and then if you run this, you'll get 7488 as your output. Okay, so that is how you can get your output, and that is how you wrote your first R code. Now before starting, our main first topic is actually vector. But before that, let me explain, or let me give you some ideas about operator. So what is operator? Well, Remember, R is a language, right? And right now I'm talking with you in a language English, right? And English language has a lot of symbol, a lot of character that we use in general, like A, B, C, D, E, F, right? Like that, operator is also like a symbol in R programming, which is used to perform different operations. And what it does, it instructs the compiler that what should the compiler do. Like for different purposes, we will use different operator. Like for mathematical operator, we have the addition, subtraction. Like for multiplication, we use the star sign. For addition, you can see we use the plus sign. Okay, there are a lot of operator like that what we are going to learn in these videos. Like while using vector, while using matrix, while using loop, we will use different symbol or different operator for different reasons. And it's not a wise idea if you try to learn all the operator at the same time right now. What we will do is that we will explain things and show it one more example at the same time. Okay, so here you can see we have like the relational operator, like the equal to sign. Here we use the double equal for some reasons. And for the logical not, to express not, we use this sign. Okay, so it's really interesting, right? So here is the idea of the operator. So let us assign a variable by using a simple operator. Here you can see I already wrote a lot of note for you so that I can follow this note and can write the code organizedly. And here you have a lot of explanation like before. So numeric variable, I hope you already have a little bit idea about the variable. Variable is something simply that can vary. Okay, so for example, x is a variable whose value is 6. Okay, so now you can define that simply is equal to 6. Okay, now if you write this line and just run this, you can see that at your output it is saying x equal to 6. Now after defining the variable, always call the variable. Call the variable means just give a name. Let's say x was the name of the variable and run x, only x. And now you can see the output is saying x. So at first you tell RStudio that the value of x equal to 6. Then you are asking RStudio, okay, give me the value of x. Then it is saying 6, right? So there is one more operator you can use. Here we use a common operator like is equal to. But in R programming, most people use this operator like x less than minus. Okay, this sign is also known as equal to. And this sign will also help us to assign a variable. So be comfortable with that. Like if I say x less than minus 6, it means x equal to 6. Now if I run this, you can see that I'm getting the output here. Now if I say x again, then you can see that if I run this, I'm getting x equal to 6. Okay, so now if you want to check the variable type, there is one more way. Like you can see here we defined a numeric variable. Now if you want to ask our programming, okay, what type of variable is this? You can use a function named as class. As I already said, there are a lot of built-in functions. So this is another function like those. Now class of x, if I run these, then I will get numeric. So our programming is saying that this type of variable is numeric variable. And now one more thing you can do, that's really interesting. If you use is.numeric, you can see that there are different options are coming on. That is why R is, sometimes very useful, or RStudio is very useful for this reason. Is.numeric, and if you give x is the variable name. Remember one thing, here the variable name is x, so here you need to call exactly the same name. Exactly the same, okay? Now if I run this, it will say true. So you are asking them, okay, x, is it numeric? Then it is saying true. That is how you can check the variable type. Similarly, you can define the character variable. Character means there are no particular value. Let's say if I define that a is equal to, and if I say male, make sure you give one inverted comma for that. Then if you define a again, or you just call a again, so let me run this line fast. It means a is equal to male. Now you're calling the variable name, that means you're asking R, what is the value of a, and it is saying male. So that is how you can define that. Now if you can ask R that class of a is equal to what? Class of a is equal to what? Now if you run this, you can see that it is saying character. So that is how you can check the class type again. Now logical operator, that's something really interesting. I'm gonna show that in a little bit different way. It's like when you are using true, false, those are known as like the logical operator. Let's see if I define c is equal to 5, okay, one variable, and then c, and then d is equal to 6, then I'm calling d. Okay, now if I run all the line together, let me run all the line together, it means you can see c is equal to 5, then I'm asking c, value of c is 5, and value of d is 6. So I'm assigning a variable value, right? Now if I ask the RStudio that is c greater than d, it will tell me that it is false, because I already defined c is equal to 5. So 5 is not greater than 6. So that is how you can just get a little bit idea about logical operator. In practical sense, mostly we will use the character and the numeric. In fact, for the character, we will convert it on factor, which is known as categorical way. So we'll discuss that later on. Okay, there is one more way you can discuss, like if I just tell you guys that, okay, how many variables we entered in total here. To find out that, there is an interesting function. If you see that, or if you check out like ls first bracket, you can see that a structure is coming on for this ls first bracket, name, and a lot of things are coming on. So it's okay if I use only the name, or if I don't use anything. So ls first bracket, you can see that 136 variables are coming on. Okay, now you must be asking, we just used a and x, only 2 variables, or maybe cd, only 4 or 5 variables. So how this variable is coming on? Well, from the last few days, I always just use this RStudio. So that is the variable list I have that I used for the last few days on this computer, okay? So don't be afraid on that. Now, if you want to remove a particular variable, there is also one more function available. Like if I use rm, first bracket, and then a variable name. Here we use c and d. So let us remove c. So if I call the c variable, you will get the output as, if you run this, then the c variable will be automatically removed. Okay. Now how are you gonna know that? Here you can see in the 11th we have c. Okay. Now if I run the ls first bracket again, let's see whether c has removed or not. Now if I run this, you can see that in the 11th variable, here it is, yeah, there is no c. Okay, so that is how you can remove your previous variable. Okay, so now let me show you one common mistake you can make. If I use large alphabet C instead of a small letter. Okay, now if you use a large letter, what will happen? Let me see what will happen. You can see that you are getting error, you are getting a warning message that object C not found. So whenever you are getting warning message, maybe you are not getting the output, maybe it's not working for some reasons, so that it means that you made some mistakes. This is one common mistake people make. Okay, so I hope you got it. So that is a little bit idea about operator. Now let us learn about the vector. So a vector is a sequence of data elements which contain different data values. This is just a simple definition. Just assume a practical sense. Just a few seconds ago we learned how to assign value in a variable. For example, x, the value of x is 6. But in practical you don't have one value, right? You have a lot of different data values. For example, if you ask 100 people that what is your salary, okay? Let's say you're collecting data set in some way about the salary. So some people may have 1,000, some people may have $2,000, some people may have like around $10,000. So you are getting different data values from different respondents, right? And always to assign different data values in a variable, you must use vector, okay? And like for defining vector, always use a function which is like the C first bracket. Okay, this function is used in R to create a vector, and like I said, it is another built-in function in R. For example, let's say the value of x is here like 8, 5, 8, 2.5, 4, 6, 6. So you can see that here we have like around 6 data values, or maybe like 7. Yeah, 7 data values. So for that, here we define it by using C first bracket this function. So let's go back to our R Studio. So here we go. Let us define a numeric vector at first, which is similar like before what we discussed. Just here we have more than one value. So x equal to, let's say C first bracket. So let's say our variable values are like 8, 5, 8, 2.5, and then 4, 6, 6. So here we have like 7 data values, right? Now let us run this variable. You can simply run this. And here we go. And then ask our programming about the variable. That means call the variable with the same name. Okay? And if you run this, here we go. You can see that here we got the output. Okay? Now, what about the character vector? But before that, you can also check the data type like before, the class of x, and if you run this, you'll get the numeric, right? And then you can also ask this like, is numeric of x? That means, is x numeric or not? So they will say true or false. Yeah, now it is saying true. So a vector can also contain string values. Okay, string values is a type of character, like the symbol, like the male, female, when you have different categories, or when you have different, like if you're asking people like, what's your name? So some people saying that, okay, my name is Saif. Some people may say that my name is Rohim. Some people may say that my name is Topu. So yeah, that is how different names can come out. Okay, so yeah, now let's go back to the character vector. Let's say that the variable name is, you can use any variable you want, or any variable name I should say. Okay, like y is equal to C first bracket, and here like before you must use the C first bracket. Okay, now you can use the double inverted comma to say the male, and then comma, and then you can use female. Okay, then you can use female. So that is how the two character we have in our variable. Now let's run this and call the variable name, and let's run both the line at the same times. Okay, now I hope you'll learn this. Make sure you practice this while watching the video. Okay, and now here we got your output, that male, female. Now let's reduce one inverted comma. Let's see what happens, whether it works or not. Okay, so instead of using two inverted comma, let us use only one, because some people may have the confusion. Okay, like he's using the two inverted comma here, whether it will work for one or not. So here you can see it is also working for one inverted comma, right? So here we go with the character vector. Now if you ask it that is dot numeric, let's see what happened. That's going to be interesting. Is dot numeric y. Okay, so you're asking our studio whether y is numeric or not. So it is saying false. That means y is character. Now ask our studio again, is it character? So it's a new function for you, which I think probably used also before, I don't know. So is dot character, if I ask this, then it is saying true. Okay, so I think before that I think we didn't use here. Okay, while defining only one value for a variable. Okay, so that is how the numeric and character variable can be defined. And then you can also define for the logical vector. Let's say z is the name of the variable, and is equal to again C first bracket. Now while using true and false, you can simply use T comma if has to be large letter. Okay, then comma T, and then comma if again. It depends how many data values you have. Okay, so if I run this, you can see that it's working, and then just call the variable name Jade, and you can see that true, false, false, something is coming up. Okay, so let us do something interesting. Let's change the variable name. Let's say for this character vector, or maybe for the numeric vector, let's say the variable name is x, y, z, a lot of things. Okay, just a random name. Let's say this is working or not, because some people may have the question like that. Now if I run this, you can see that it's still working, but here the variable name is very complicated. I just changed the name just to explain you. Now let me do one more thing. Let us use a space between the values of the variable name, and let's see whether it's working or not. Okay, now if I run this line, it is saying that unexpected symbol in X, Y, Y, Z. That means remember this thing. You cannot use a space in between the variable names. What you can do, you can just use underscore. Okay, just use underscore. And if I use underscore, let's see whether this line working or not. And let us call this using the same name. Okay, XY underscore YZ. That you can see that RStudio is helping me to get it. Okay, instead of writing that. Now if I run this, here you can see that it's working. Okay, so let's use hyphen. Let's see what happened. Okay, let's see what happened. So I'm using hyphen instead of underscore, and you'll be able to see that it's not working. So remember that whenever you have a space, always try to use the underscore in variable name. Okay, so that is the idea of different types of vector, and what I just try to show the most common 3 types. Okay, in general there may be 1 or 2 types which we don't need to learn that much. Okay, so yeah, that's the idea of vector. Now one more interesting thing is that create vector using different function. So instead of using the C first bracket, you can also create vector by using different function for different purposes. Okay, like here I have the sequence function. Okay, let us say the variable name is y, or you can use any variable. As I said, y is equal to let's say sequence 1, 20. Now let's see what happened. And if I call the variable name y, and let me run this, or maybe instead of using y, let's use xy. Let me run both the line at the same time. Now look at that, you are getting all the value from 1 to 20. Or what's happening, you may be confused, right? They're getting 1 to 20. Like if I use comma 1, let's see what happened, or maybe comma 3, I should say, comma 3. And now that's interesting, you're getting 1, then there is 3 times distance, then you have 4, again 3 times distance, then 7. So that is how it works. So the meaning of this is that it is starting from 1. So the first value is the starting value, the second value is the ending value, and in between 1 and 20 you will always have 3. Okay, you will always have distance of 3. So the third value is actually defining, or it's about that how many distance you want to have in your data values. So in some cases it may be really useful for having different operation in your vector, okay, or in your variable in the data set. So now some people may be asked, okay, why the last value is 19? Because you can see that while ending the 3, that the even number 20 is not coming out. So if I use 5 here, let's see what happens. Okay, let me run this again, the same one, let me run this, and you can see that it's saying 1, 6, 11, 16. So if I use 4 distance between 1 and 20, you will get something else. So that is how it's working. Okay, so now let's see, if I asking you, okay, 1 to 20 having a distance of 2 units, let me just ask you that 1 to 500, let me change the questions. Okay, and having a distance of 50 unit. Okay, and let's say the variable name is my name, Saif is equal to sequence 1 is a starting value, ending value is 500, and distance is 50. Okay, and then if I call the variable the Saif, and if I run this, you can see that you're getting 1, then distance of 50, then 51, then 101. That is how this function is working. Remember, sequence is also a built-in function in R. Okay, that is we're simply calling this, and it's working very easily. Okay, now by default it always have 1 unit distance. That is why initially when I didn't define that, like 4, if I remove 4, by default it will always have distance of 1. You can see that always have 1 distance. Okay, so also remember that. Now let me run one more let us learn one more function that is known as the repeat function. Okay, it is something also really interesting. Let's say that you want to repeat the value 2 for the 5 times. Okay, so for that, let's say the variable name is z1 is equal to repeat, AREP. This function is used to repeat any variable, any value of a variable. Okay, so let's say 2 comma 5. Now if I run this and call the variable z1, don't forget to call the variable. Okay, if I click z1, and then it's okay if you just run the last line. Okay, now you're getting 2 for the 5 times, 1 2 3 4 5. Okay, now let's say another question here. 1 2 4 will be repeated 5 times. That's something I'm going to do really interesting. So z2 is equal to first bracket. Now inside the first bracket, they are saying to 1 2 4. Now how are you going to use that? You can just use the vector inside this repeat function. Okay, make sure you use the repeat at first. So inside repeat, I use a vector to define the value 1 2 4. So 1 comma 2 comma 3 comma 4. Now comma 4. It means that this vector will be repeated for 4 times. Now if I run this and call the variable and run both line at the same time, you can run one by one. So here you can see 1 2 3 4, again 1 2 3 4, again 1 2 3 4, again 1 2 3 4. So these 4 values are repeating for the 4 times. Okay, so you can, instead of using the vectors in here, there is one more smart way you can deal with that. Okay, like if you say 1 is to 4, it will automatically count that as 1 2 4. Okay, so if I run this, it will also working. You can see that it's working. So I hope you got the idea how to do a little bit different type of operation inside the vector. There are a lot of functions available in RStudio. Here you can see that we have just a long video, so I'm just describing some of them, and I believe this is the most important one and the most common one. So yeah, that is the idea of vector. Okay, so now we will discuss about matrix. So what is matrix? In R programming, a matrix is a collection of elements which can be arranged into a fixed number of rows and columns. Okay, just for example, here you can see a matrix. What does I mean by rows and columns? You can see that here you have like 1 4 7 10. When you consider that as horizontal way, okay, then it is called as rows. So here we have 1 2 and 3 rows in horizontal way, right? And when you consider that in vertical way, that is known as columns. Okay, so here we have 1 2 3 4 columns in total. Okay, so I hope you got the idea about rows and columns. So the difference between vector and matrix is that vector is just like one dimension, only one dimension. Here you have 2 dimensions. Okay, and a real data structure is almost looks like a matrix. Let me show that with an example. Okay, so here we have, let's say in real situations, here we have 3 questions. Let's say you are asking this to a lot of people for collecting the data set. At first you are asking them, okay, what's your ID number? Then you are asking them, okay, what is your gender? And you are giving them 2 options. That is like categorical variable. 0 for female, 1 for male. Okay, and then you are also asking them, okay, what's your age? So you're asking them 3 questions, and let's say you're asking them only 4 respondents. That means 4 people. And the first respondent answer is like ID number 1, and 0 means female. So she's saying I am female and her age is 25. For the second person, you have 2 1 35. So 2 means ID number 2, and gender 1 means male category, and age 35. So that is how you got the data structure, which you can see that here you have rows, 1 row, 2 3 4. You have 4 rows and 3 columns. Okay, so you will try to use the concepts of both vector and matrix and try to enter the data set. But before that, let us learn a little bit basic how to create matrix. So here you can see we have a lot of notes here by just explanation of all those things about the definitions and like how to create matrix. So let's start with that by using rbind and cbind function. Remember, there are 3-4 common ways you can create matrix, but here we are using the two most efficient ways how to create matrix. Okay, so what do I mean by rbind and cbind function? Before going to that, always remember, to use these functions you must create some vectors at first. Okay, so let us create some vectors. Let's say x1 is equal to c first bracket 1 2 3 4, just 4 numbers, which is for x1 variables, and then x2 is equal to I hope you already learned about how to create vectors very clearly, and 5 6 7 comma 8. So that is the value of x2 variable, and I'm calling the variable name, and then x3 is equal to 9 comma 10 comma 11 comma 12. Okay, and then I'm calling the x3 variables again, and if I run all these variables, you'll be able to see, okay, it is saying a cross sign. Okay, that means you did something unexpected. Now let me run that, and before running that, you can also here you can see that, but let me still run that. Let me find out what's wrong I did. Okay, so that's gonna be an interesting experience. You can see that it's saying unexpected x3 is equal to 9. So what is unexpected here? Here you have not wrote c first bracket function, which is for defining vector. Okay, so let me run all the vector again. Here vector is just to create some variables. Okay, so here we have created 3 variables. You can see that you got all the output. Okay, I hope you already learned that. And now let us create a matrix by using these 3 vectors or these 3 variables. By using rbind function, you can create the matrix in row ways, and by using cbind function you can create the matrix in column ways. You can use both option depending on what you want. Okay, let's say I want to use in row ways. That means all the 3 variables will come out in row wise. Okay, so here to do that, let me define a name. Okay, this is just a name of the matrix. You can give any other name. So I'm giving like MATR is equal to rbind x1, and then x2 will come out, and then x3 will come out. And let me call the name MATR, which is the name of the matrix, and let me run both line. Okay, now you can see that a matrix has created, but you can see that x1 in row wise, x2 in row wise, and x3 in also row wise. Okay, now to understand the difference, let me show that in column wise. Let's say the name is right now MATC is equal to cbind. Cbind will allow us to have the output in column wise, x1 comma x2 comma x3, and then let me call MATC again, and let me run both the line. Now you can see that x1 1 2 3 4 first column, 5 6 7 8 second column, 9 10 11 12 third column. Okay, so here we have in total 3 column 4 rows, but before the last one is rbind, where we had, like you can see that 4 rows 3 columns. Okay, so you can clearly see the difference between rbind and cbind, and it's better if you first determine that what way you want. Okay, let's say you want in column ways, then you can just just enter the number in column wise and then call the variable accordingly in your rbind or cbind option. We'll get back to that again by entering a real data set. Okay, now let me show that one more way using the matrix function, which is also one more built-in function in our programming. Okay, now to do that, let me give a name. Let's say y is equal to matrix is the function name, then give a first bracket, and let me create a vector that means 1 is to 20, which means 1 to 20. Accordingly the value will come out, and comma and row. You can just define the row numbers, and now if you try to get the output, okay, let's see what happened. So you define that the value is 1 to 20 and the row number is equal to 4. And if I run this, you can see that 1 to 20 and the row is 4. Now you can ask me, okay, here we have 1, 2, 3, 4, 5 columns. How this column has created? Okay, by default, it always understands. So when you tell them how many number of rows, by default, it will have the number of columns. But if you want to mention the column number, you can also do that. Okay, let's say n column is equal to 5. N column is equal to 5. Now you can see that it will also work. So here you can see it's working. Okay. But now if you try to use the column number 6, you'll not probably get the output because you do not have enough values to get the output. Okay. You can see that it is saying the data in 20 is not a submultiple or multiple the number of column 6. So you can see that there are some problems are coming out to have the it is having the same column again in the sixth column. Okay, the first column is repeatedly coming out. So it's not a wise option to do. You must know that how many row and how many column you want in your data set. Okay, now you can also define that by using that. If I say by row is equal to true, it means that the output will come out in row wise. You can see that 4 rows and 5 columns. But now if you define that by column, it will be something really interesting. Or I should say that not by column, it will not work. You must use by row is equal to false to have the output in column wise. Okay, so you can see that if I run this, now look at that very carefully. Some people may feel confused. The first one is by row wise, that means row wise. Now you can see that 1, 2, 3, 4. Then coming out second row 6, 7, 8, 9. Then third row 11, 12, 13, 14, 15. That is how the output is coming out. Now look at this. When you are saying by row is equal to false, that means you want the output in column wise, vertical wise. Okay. Now look at that. 1, 2, 3, 4. First column. Then 5, 6, 7, 8. Second column. Then 9, 10, 11, 12. Third column. That is how the output is coming out. So that's a smart way to create a matrix. I actually prefer the fast way more, okay, because I feel more comfortable on this. It's up to you, whichever method you are comfortable to define matrix. Now, what about the dimension name? Well, you can use the dimension name and check out that how many rows or columns are there. Let me use dimension of y. Dimension of y. Or you can just define that by x, the previous one. But it's okay if you define it to y. Now, if I run this, let me see what happened. You can see it's saying 4, 5. 4 means 4 number of rows are there, and 5 means 5 number of columns are there in your y matrix. Okay. Okay. So now something interesting. You can also define the name. Dimension names of y is gonna be a long line. Okay, is equal to list. There is an option which we'll discuss more later on. List will allow us here to write the dimension name. So list is equal to R1. Let's say R1 is the first row name, and second row name is R2, then third row name is R3, and fourth row name is R4. Okay, and you can see that here we have four character we used. Okay, so you must use a vector sign. So this vector sign will allow us to define the row name. Now the column name. Okay, now the column name. We have 5 columns in y, I think. Okay, 5 columns. So C1 is the first column name, let's say, and then C2 is the second column name, and then C3 is the third column name, and then again C4 is the fourth column name, and again C5 is the fifth column. And I hope I didn't make any mistakes while using comma and inverted comma. Try to be very careful. I know if you're a beginner as a programmer, a lot of mistakes are always coming out, and you'll always be confused. Okay, I'm just just messed up all the time. So don't worry, just practice again and again and try to be smart. Okay, and try to be smart while writing code and finding the mistakes. Now, if I run this, let me see what happened. Let me see what happened. You can see that the dimension names are running successfully. Now if I call the matrix y, If I call the matrix y, let's see whether this dimension name is added or not. So now look at that. In the row number, in the row 4th row, R1, R2, R3, R4. In the column number, 5 new names are added. Okay, so for that we used a built-in function dim names. So I hope the idea is clear to you about the dimension names. Now let us enter a data set using the concepts of vector and matrix. Just a few minutes ago I described that by using a slide. I hope you remember that. Let me show that in the slide. Here you go. Here you go. You can see that here we had 4 respondents, right? Like 4 rows and 3 columns. So now let us enter the same data set in our RStudio, and for this let's say we determine that we will use the cbind function, okay? And for that we need to create the variable in column wise, not row wise. So we have 3 columns here: ID, gender, age. So first column is 1 2 3 4, second column is 0 1 1 0, third column is like 25 35 21 45. So we will first create these 3 variable which is in column wise, then we use the cbind function. So let's do that in our RStudio. And so here you go in our RStudio, and let's say the first variable name is ID. ID is equal to C first bracket 1 comma 2 comma 3 comma 4. Okay, and then gender is equal to the first person was like female, then male for 1, female for 0. I have to remember, okay, 0 1 1 0. And the third one, let's say age is our third variable. So age is equal to C first bracket, it was like 25 35 21 45. So we are done with creating these 3 variables. Okay, let me run this first. You can see that here it is run. You can just check the output also by calling the variable name. Now we do not need to do that. So let us directly create our matrix for these 3 variables. Let's say the matrix name is data entry. You can give any other name you want. Okay, and use the cbind function and call the 3 variables with the same name. Okay, ID, same name, gender, and the third one is like age. Okay, so now just run this and then call the name to show the output data entry. Okay, here we are missing A. Okay, now let me run this. So here we go, boom, here you got the output. So you can see that we got the output the way we wanted. Okay, ID, gender, age, and here the 1 means first respondent, 2 means second respondent, 3 means third respondent, and 4 means fourth respondents. Okay, that is how our data structure looks like, and that is how we learned vector and matrix. Remember one thing, matrix is not the best way to show the data structure. There are one more thing, we learn the data frame. Okay, because at data frame there are different options or advantages over matrix. Okay, and also one more thing, that R is not for entering the data set. For entering the data set or for the data entry, you have Excel, you have SPSS, a lot of softwares are there. Okay, and this is more like the data analysis, visualization, cleaning, as I already said at the starting of this video. Okay, and then the diagonal. If you want to check out the diagonal, you can also find out that let's say diagonal, the diagonal values in the matrix. So data entry. Okay, data entry. If I run this, let's see what the output I'm getting. So I'm getting 1 1 21. So that is our diagonal value in this matrix. Okay, so to be more clear, let me also show that the diagonal of y. Let's see what happened. Diagonal of y. Okay, diagonal of y again, and 1 6 11 16. That is our diagonal value of y matrix. Okay, so that's a little bit idea about the matrix, and there are a lot of things you can learn on that, a lot of different options. And you can see that here 1 6 11 16, these are the diagonal values. Okay, so let us describe a little bit more like how to do matrix addition and subtraction, and then the important one, like how can you find a subset or selecting specific columns and rows, which will be very helpful even while we discuss the data frame. Okay, so matrix addition and subtraction. Remember that to add two matrices, number of rows and columns needs to be equal in both matrices. Okay, number of rows and columns. So let us create a matrix and try to add that. Okay, let's say m1 is equal to, let us create some vector first. M1 is equal to C first bracket, then 3 comma minus 1 comma 2, and then M2 is equal to C first bracket 9 comma 4 comma 6, and then let us create the matrix number 1. Matrix is equal to, let us use the R bind M1 comma M2. Okay, you can also use the C bind as far as you want, but you must create the variable in column wise then. Okay, and these are say M1, and let us create M2 another matrix. For that, let's create another two variables. M3 is equal to C first bracket 5 comma 0 comma 3, then M4 is equal to C first bracket 2 9 comma 4. I'm just using some value randomly. Okay, and then MAT matrix number 2 is equal to R bind M3 comma M4. So here I am created two matrix, and let me run that, and boom, here we got the output. So to show the matrix, let me call the matrix mat1 and mat2. So if I run mat1 and mat2, here we got our output. Okay, so here you can see. So that is how you can create the matrix. And let me just do the subtraction or the addition. You can easily do that. Okay, just use a name. If you don't want, you can avoid using name, it's your choice. So addition is equal to mat1 plus mat2. I repeat, you can use any other name instead of using addition. And if I just run this and call the addition, and then if I run this, let me show what happened. You can see that a new matrix coming out, which is the addition of these two matrices. So 3 plus 5, the first value you can see is 8. So that is how actually the addition is done. Okay, like 9 plus 4 13, 6 plus 4 10. Okay, look at the whole matrix, then try to use every number on the same way. Okay, and then for subtraction, you can directly do that, or you can create a variable named subtraction. Let me try to directly do that, like mat1 minus mat2. Now if I run this, what I will get, here we go, you can see that I got an output of the subtraction of these two matrices. Okay, so yeah, we have done a lot of things on matrix. Those are not highly useful for analysis, but this basic can really help you to go further to deal with the data frame. So here we go with the subsetting, extracting of a matrix. Like here, if I ask you, select element from the matrix which is in the second row and third column. Okay, so let us call the matrix the data entry. Okay, let's say we will use this matrix for that. Now I'm asking you to select element which is in the second row and third column. So how are you gonna find that? To find that data entry, use the third bracket. Okay, whenever you want to select a specific element, I repeat, a specific element, not the rows, not the columns, only one or two. So I'm saying that it is in the second row and third column. So use the row number first. Second row, then the column number. Okay, so then just run that. Okay, then just run that. Now here you go. You got 35. So 35, you can see that 35 is in the second row and third column. So that's the value we are looking for. That's the value here we have asked. Now the second questions. Let's say you are asking that subset column or row, or selecting second row only. Now we are asking a specific rows, not a specific element. Okay, and interesting thing is that here we are asking only a specific one row, not we are not mentioning any kind of column. So for that here you need to select 3 elements here, right? The 3 elements, second row. And for selecting all the elements, as I said, you can use the third bracket. So at first use the matrix name data entry, then give a third bracket, then just use the row number. Okay, now do not use any column number, just give a blank here. Okay, any column number I'm not using. So if I run this, you can see that I'm getting the second row. 2 1 35 is our second row. Now if someone is asking to select the third column, the same way, data entry, third bracket, comma. Now do not use any row number at first, just use the blank or in the rows. Okay, now use the column whatever it wanted. It is asking third column, so data entry comma 3. Now if I run this here, I'm getting the third column. You can see the third column is what? The third column is age, which means 25, 35, 21, 45. That is what I got. Okay, that is how you can select column, rows, or a specific one element or more than one element. Now let's see that I'm asking to subset or to extract multiple elements. That means I'm asking you to select element which is in the second row, second column and third column. That's going to be interesting. Data entry, third bracket. So it is already given me data entry, third bracket, and second row means 2. Now it is asking second and third column. So it is asking 2 columns. So whenever you have more than one value, always go for vector option. Use the C first bracket function and then 2 comma 3. Now just run this. Here you can see you got your output 135, which is in the second row. Here is the second row and second and third column. That means I'm asking 1 and 35. Don't forget the ideas of rows and columns. Okay, don't just mess it up. Okay, this is row, and when you click the vertical way, this is column. Okay, and then it is asking to select element for the second row, third row, and first column and second column. So almost the same way, data entry, third bracket, asking second and third. So C first bracket 2 comma 3. Here it is asking 2 rows, then 2 columns, first and second. So if you run this, you will get the output very easily. So I hope the idea is very clear to you. Now the next one is more interesting. It is asking to select all the rows except the first one. Now to do that, you can easily just use the data entry, and for that third bracket again. So it is asking to delete the first rows. Usually you can see that deleting the first rows. So use the -1 in the first row, and it is not asking anything about column, so just use blank again. Now if I run this, here we got our output. You can see that the first row has deleted. Okay, to be clear with that, just use that. Here you can see the first row was like 1 0 25. You can see that here it is deleted. Okay, so the last one, it is asking select element which is greater than 2. Now you can easily do that. Data entry, third bracket. So it is not asking about any columns. Okay, so it is asking all the values which are greater than 2 from that matrix. So inside the third bracket, mention the matrix name greater than 2. Now if I run this, I will get all the elements which is greater than 2. The last one is asking to select even number only. So when even number will come out, okay, for that we'll use another operator. So data entry, third bracket, then and there is one more operator like the %. It will give you the reminder. Okay, the reminder. Data entry, you can use that option, %2 is equal to double equal 0. So what does it mean? Okay, what is about even number? Even number means when you divide a number divided by 2. When a number divided by 2, it has to be equal to there should not be any kind of remainder, right? The remainder has to be equal to 0, right? Let's say is equal to 4 divided by 2. You will get 2. Here the remainder is equal to 0. So that is what is known as the even number. So here I am using the same condition. % is an operator which is used for remainder. And for equal to, logical equal, you must use double equal. You must use double equal whenever you are trying to show some logic. Okay, so if I run this, I will get only the even number because I am using the condition inside the third bracket. So the even number is 2400. Remember, 0 is also an even number. Okay, so that is the whole idea of matrix. Okay, so now we will discuss another important topic named as data frame. So what is a data frame? Well, data frame is a data structure which can contain and store different type of data set most appropriately. Why most appropriately? Why not matrix? Well, it's almost similar like matrix. Like here you also have like the rows and columns, so it is like the two-dimension way. Okay, but the advantage is that it can contain element of different types. Like it can contain character, it can contain numeric vector also. Okay, so let me show you that how to create a data frame. Okay, so for that, let us create some variables. Here I already input a lot of nodes, also a lot of example. Okay, so just to show you, then let us create a variable named as id is equal to, let's say we want to create a variable id for 6 people. That means you are asking, or you're taking the data set from 6 people. Then another variable, let's say gender is equal to, and let's say here you also have 6 categories. Then some people are male and some of them are maybe female. So that is how you need to create 6 category. Okay, so the third one is, let's say, female. And then the fourth one, let's say also female. And fifth one, let's say male. And sixth one, let's say male again. Okay, so here we have created 2 variables. Now let's say you're creating another variable. Let's say the another variable is age. Okay, just using some random name. You can use any other name you want. Let's say 25, then 35, just using some random age. Okay, so I think we are done with our 6 number here. Now if I run this, you can see that this is running very clearly and with no problem, and you can call the variable name you want, id, gender. Make sure the name is appropriate and the name is exactly similar like the previous one you mentioned. Okay, so and then age. Okay, so then let me call the variable name and let me see whether we are getting the output correctly or not. So you can see that we're getting the output very well. Okay, so now here let us create the data frame. To create the data frame, there is a built-in function named as data.frame. Okay, this built-in function will allow you to create the data frame very easily. So let's say I'm using a name, let's say Saif. Okay, you can use any other name. Saif is equal to data.frame. That is, the name of the data frame is Saif, and the data.frame includes, just mention the variable name. You do not need to use the rows. Okay, you just need to use the columns only here. So that's the interesting part here. So the column name is, let's say, id, and second column name is gender, and third column name is age. Okay, third column name is age. And if I run this, and you'll be able to see that it's running correctly, then call the data frame name. Okay, and if I run the data frame name, that means I'm calling the data frame. Here you can see that the output is coming very clearly, right? Here you have 6 rows and 3 columns. So all the columns means all the variable you have. Okay, so now if you want to display the data set in large frame, like if you can use a function named as fix, and then the data frame name Saif, and if I run this, you'll be able to see a structure is coming out, right? Here you can see the id, then the gender and age. Okay, the reason that, like using data frame is very easy for understanding the structure. You can find out the summary, all the summary together. Okay, so just use a str. This function will allow you to see the structure of this data frame. Now if I use str Saif and if I run this, you can see that a lot of informations are coming out, right? That means it is saying that you have 6 observations, which means you have 6 rows. It's also saying you have three variables, and like the ID type is number, gender type is character, and age type is number or numeric, I should say here. Okay, so you can see that all the types are coming together very easily. So, and if you want to check the summary, there are 5 number summary, like the first quartile, second quartile. Let me find out that by using a summary function and then name the data frame. Okay, and then run this. If you see that all the informations coming out, like all the analysis, all the descriptive analysis. So for age, you have the minimum age, you have the first quartile, that means 25th percentile. The median means 15th percentile. Then again the mean, the third quartile means 75th percentile. Then the maximum value. Well, here in our goal or in our objective is not to show you or not to explain you like how all this value meaning, or not to show you the descriptive analysis. Here our objective is to show you some of the basic ideas only. Okay, so that is how the data frame can really work. Now let me show you some of the operation in the data frame, like how can you select any specific row or element or column, which is exactly similar like what we did while showing the matrix. Okay, so let me show just one or two examples just to recall that. So it is saying that select an element which is in third row and second column. So to call this, just use the data frame name at first, then give a third bracket, and inside the third bracket this will allow us to call a specific rows or columns or element from the data frame. Okay, like what we did for matrix, as I already said that. So third row means 3 and second column means 2. Okay, the first value means the row number, the second value means the column number. Now just run that, you will get the output as female. Now you can see that at your data frame you can see the third row and second column is female. Okay, that is how you are getting the output. Now selecting a specific column, let's say to select column number 3. Okay, so to do that, type third bracket, and just give a comma because here it is not asking any kind of row name. So you can just use the blank in the row name option like what we did for matrix. And the column number is 3. Now just run this. So now you're getting the output. Here you can see this is column number 3. That means there we have the column number 3 is like the age. Okay, so now using $sign you can call a specific variable in the data frame. There's something really new to you because you may not be familiar with that. You can also use a $sign. Okay, just use the data frame name, then use a $sign. Now just mention whatever the variable you want. Let's say I want the gender. Okay, now if I run this, you can see that I'll get the variable of gender. Okay, so that is how you can call any specific variable only. That means you're calling a specific column. In fact, okay, variable is in the column. Okay, now how we can extend the data frame, that means like here you have around 3 variable, ID, gender, age. Now let's say I want to add one more variable. Okay, let's say I want to add let us create a new variable. Let's say our new variable is salary. Okay, salary is equal to, let us use the salary of 6 person. Okay, so I'm just assuming some number, so then 2000, then maybe 3000, then maybe like 4500, and then at last let's say 5600. Okay, so now let me run this, and to add this variable in the data frame. Okay, so what you can do, you can use a function named as cbind. Cbind, what we learned for matrix. Cbind will allow us to add a specific column. Okay, so cbind, the data frame name was like Saif, and then comma, new variable, salary. Okay, salary. Now if I run this, you can see that, okay, saying something is error. That means there are something wrong I did. You can see that the spelling has to be very accurate. Here S has to be large alphabet letter. Okay, now if I run this, here you can see that a salary has added in the data frame, right? So that is how you can add the data frame. Now you can just simply change the name, or just use the same name, that Saif is equal to, that means Saif data frame will be replaced by the cbind function where we add a new variable. Okay, now if you can directly use the data frame name to get the output with a new variable. So here we go. So yeah, that's what the idea of the data frame. Now here I mentioned that how to add a column. That is what I just showed here, that how can you add a column. Okay, now let me show you that how can you import a data set and it will come out in a data frame format. Then you can just a little bit like finding the structure, summary, just show you a little bit. Okay, there are different ways for importing the data set. Even there are some special packages that are available too for that. Now here we are using the most easiest way to import a data set, okay, but in using CSV format. Make sure you may remember that. So let me use the data frame name. Let's say data set. Okay, let's say I'm just going to give a name. Data set is equal to, I'm using a function named as read.csv. What I'm choosing? Read.csv. Then give a first bracket. Then just use file.choose. File.choose. Then just give a first bracket. It will allow us to call the file wherever it is. Okay, let me just run that. Let me show you how it works. Now if I run this, you can see a new window is coming out. Now select the data file from any folder you want. Let's say I'm selecting a data set from this folder, and the name of the data file, let's say salary data. Okay, now let me call the data set name. Let's see whether it works or not. At first you need to run that. Okay, it runs successfully. Now calling the name with the data set. Now you can see that it's saying object data set not found. Okay, that means I have done a little bit mistakes about by inputting the number. So let me call that again. Or what you can do, you can just easily call this name, dat set. That was the last name. Okay, by mistake I used the dat set. Okay, so now if I call the dat set the same name, you can see that it works, right? So you can see that a lot of variable is coming out, like minority, stress, and then here we have the gender, birth date, education. A lot of things are coming out. So here my objective is not to just show you how to prepare the data set, how to manage the data set. I'm just showing you to give you some basic idea. Okay, so now if you want to open the data set in a large screen like before what you did, fix dat set. Okay, dat set, and if I run this, the data set will display in a big screen. You can see that. Okay, so yeah, that is how you can import the data set. Now as I said already, it is in a data frame format. So you can find the structure, like a structure, dat set. Then if I run this, let's see what happens. You can see that it is saying the data type, how many observations, how many variables are there, and some of the values are shown. Okay, and then you can find the summary like what I did previously, summary function, then the data frame name, dat set. Okay, then if I run this, you can see that the minimum value, the first quartile, the medium, mean, third quartile, maximum value is coming out for each variable. Okay, so from that where you can get a lot of information, and I hope the idea is very clear to you. So yeah, we are done with our data frame and importing the data set all the way. Okay, so now let us show you another topic named as the factor and list, and later on we'll also provide you some of the a basic idea about the packages. Okay, so what is factor? Okay, factor is used to define category in a categorical variable. Like previously we have mentioned the gender, which have two categories, male, female. Now if you check out that the class or the type of the variable will coming out in a character wise. Okay, so factor will allow us that it will tell RStudio that it is a categorical variable and these are the category. And even if you have ordinal variable, you need to mention the rank, you can also do that. Okay, so let me show you how can you use the factor. Before that, let us call the last variable we created, I think for gender. Okay, so let me just copy the variable name gender, which have like 4 categories, let's say male, female, male, female. Now let me run that and let me show you. Here you can see that in the output the male, female is coming out. Now if I check the class of gender, let me show you how it works. Class of gender. and you can see that it is saying character. That means the gender type is character. Okay, now let me do something interesting. Gender is equal to factor. I'm using a function named as factor gender. Okay, that means gender variable will be replaced by factor of gender, and factor of gender means what? Categorical variable. Now if I run this, okay, and if I check the type of the gender, you will see what happened. That is saying that factor, okay, the class or the type has been changed. Okay, that is how you can convert that by using factor very easily. Now let me show you just a much more clear example. How to define value in each category. Let's say that gender is a variable which have this value, okay, 1 2 2 1 2. Now in practical sense, when you inputting the data set, like before that you must have a lot of questionnaire. You're collecting the data set from different participants, right? Now in questionnaire, maybe it means 1 means female, 2 means male. Okay, so while entering the data set, you will only use the value and you just convert it to the category. Let's say you have the value and you need to convert it to the category, and you can easily do that by using factor. Okay, to do that you can just use gender again. Gender variable will be replaced by factor of gender. Now inside this factor you can use levels and levels. Okay, so what does it mean by levels? Okay, so if I use you can see that there are a lot of options are coming out as a help. Okay, levels is equal to C of, I'm using the vector because here I have two value, 1 comma 2, and comma levels is equal to C of male comma female. Okay, male comma female. Now you can see that it means that these two category, which level is 1 and 2, 1 for male, 2 for female. You can use any other code you want, okay, depending on the code you have in your data set. And then if I run this, let me run the first line at first only, and let me see the output. Okay, let me see the output, gender. And if I run this, you can see in the output is saying 1 2 1 2 2, something like that. Now if I run this line and I'm calling the variable name again, okay, I'm calling the variable name again, and now you'll be able to see that it is saying there are two levels, male, female, and all the values are converted to male, female. Okay, so that is how the idea of factor and converting it category or mentioning the category really works. Now, how to define order in the category? Okay, that's something also really important. So now to define order, let me just use a variable, and let's say the variable name is economic, okay, which value is like 1 2 3 3, something like that. Okay, here you have, let's say you have 3 category. That means you're asking people what's your economic status. Some are saying rich, some saying middle, some saying poor. So here these 3 rank, the rank is important, okay, because which one comes first and which one comes second, which one comes third. Okay, here the rank is really important. I hope you have idea about this ordinal variable. Okay, now let me run this. Let us try to convert that into an ordinal. And to do that, just use the factor function similarly like before. Okay, just completely similar. Let me just copy that and show it. And you can see that here we have this economic new variable, which will be converted to factor where the levels are 1 2 3. And levels means rich, middle, poor. That means 1 for rich, 2 for middle, 3 for poor. But now here we are adding an additional option. Order is equal to true. You can see that previously we didn't add anything like that. So when you're using order is equal to true, that means RStudio understands that you're saying that this is an ordinal variable. Now if I run this, let me see how it happened, or whether there is something about ordinal or not. Now if I run this, you can see that in the levels it is saying rich less than middle than poor. So that is how it works. Okay, you are just continuing an ordinal way. So yeah, I hope the idea is clear to you. Okay, so now let us discuss about the list. What is the list? Well, list is the object which contain element of different types. Like it can contain number, it can even contain matrix, it can even contain data frame. Everything it can contain inside this list function. Okay, So now list can be created by using list first bracket function, and let's do that. Let's say we're creating a variable. Let's say it is x is equal to list, and inside this list let me use a character vector at first, male comma female. Then let me use a numeric vector c of 1 comma 2, and then let me use a logical vector true false. Okay, so now let me run this. You can see that it will work. In usual way it will not work. Okay, that is why list is something really important, but in practical sense we really don't use list that much because it's not highly necessary in practical sense that much, but in some cases it can be really useful. Okay, so now let us create a list. Let me do something really interesting. You can see also, you can see that before that, you can see in the output that you can see that the value of x is male, then female, then 1 2, so it is coming in an organizing way, right? So now let us create a list which includes vector, also matrix, also data frame. Okay, so let me copy the vector I showed and matrix or data frame I showed, and here let me just copy that. Here you can see that this is the vector we have. Okay, so let me run the two vector we have, x1 x2. Then let me run the matrix we have. Okay, it is for y, and then let me run the data frame we have. Okay, so now let us create the list. Let's say the name is all in one is equal to list, and the name of the vector was like x1 comma x2, and matrix like y, and then data frame name is if. Okay, now let me run this and then call the list name all in one. Okay, exactly the same name all in one. And now if I run this, you can see that that's coming in a very nice way, right? Is the vector, again the vector, again the matrix, again the data frame. Okay, so include the list. Here we have everything. So that's the whole idea of list. Now let us discuss about R packages. I think you already got some clear idea about a little bit about R packages, like what really R package is all about. But let me show it again a little bit more. Just to install the packages, I already described that you can go to the package and you can click the install. Okay, you can see that it's coming a little bit slower in my computer for right now. Okay, here you can see that package. Let me just use the name ggplot2. Now if I click the install, it will be installing. Okay, now in my computer it is already installed. Okay, so it is asking that to restart or something like that. So now let me say no, and now you can call that using the library function also. Okay, so let me call that or instead of using library, before that let me tell you guys that instead of using these options directly, you can use another function named as install.packages. Okay, inside this function just use the package name and just run this to install the packages whatever you need. And then another option like the library. Say for example, in your RStudio a lot of packages are already installed. Okay, and you want to call a specific packages for some analysis. It is known as the, like, if you want to load the packages. Okay, so in my computer, let's see how many packages are loaded. So I'm using the library function. You can see that all these packages are already loaded or already installed in my computer. Okay, so I just need to load that. Now if I see that if I check the if I use the library ggplot2, it will load it. Okay, that means it is already installed. Now I want to load this. Let's say I want to just today I decide that I will draw some data visualizations. Okay, so for that purpose I use the library. Now this function is also used to call the packages. Yeah, that is what. And the search option, the last option. Search option means to see packages that are currently already loaded. I repeat, library is allowing you to see packages that are already installed, but search option means it is already loaded. So how many are loaded? You can see that a lot of packages are loaded. Okay, just a few seconds ago I loaded ggplot2. You can see that it is in the search option. So yeah, that's a little bit idea about packages. Now let me give you a little bit more idea about how to ask help. Okay, for example, here we used a lot of functions, right? Let's say we use the factor. Now if I give a double questions and use the factor and just run this, you'll be able to see that in this help options a new window is coming out, right? A new window is coming out, like a lot of options are coming out. Like it is saying help, okay, it is saying the help related to factor, what type of help do you need? Okay, so now if I use, instead of using factor, let me use the matrix function. Matrix, let me see what it's saying. So if I run the matrix, search result, a lot of search results are coming out in the help option. Now let me just click the search result. You can see that a lot of PDF, a lot of sources are coming out. And if I click this introduction to matrix packages, okay, now let me see what is coming out. If I just click that, it will take a little bit time sometimes to come out, okay, or you can just go to the PDF source or R code, whatever you want. Okay, so it is coming out. You can see that in a with a PDF format, like which have a lot of structure and a lot of things include that. Okay, so now you can follow that. You can ask help to R whenever you need. Okay, help pages, let me click one by one. Let me just use only one question mark. Let me see whether it works or not. Matrix, okay. Now if I use only one question mark, you can see that now there is something about the basic ideas are coming out, like what is already in R. It's not just exactly the PDF or source that what we did before. Okay, now here the description, like matrix creates a matrix from the given set of values. There's the ideas of definition, there are a lot of argument, a lot of ideas of function, and at last you'll have some example also, like how can you just run a matrix. Okay, so here you can see that you can copy the example and follow the code whenever you need. So that is why R is much more easier to use. Okay, though for some people it may be difficult who have no idea about programming languages. Okay, so I hope that you're having a good start and try to practice as much as you can. So there's the idea of packages and asking help. So right now we are going to discuss another topic on this R programming, like how to use if-else in R. Okay, in every programming languages, this topic is very common. Like at some purposes or some cases, you may need to use some conditions, okay, to solve a particular problem. For example, here we are going to discuss 2-3 problems to show how can you use if-else. So before that, just have a little bit idea about the basic structure, how the basic structure looks like. You can see that at first you need to use if, then you just need to use a first bracket, and inside this first bracket you need to mention the condition. Okay, so then give a second bracket and give a statement. Okay, statement number 1, let's say. So what does it mean by a statement? That means if this condition applies, then this statement or this formulas or this procedure will come out. Otherwise, then use else. Okay, else, that means if this condition is not true, then use a statement number 2 or follow a statement number 2. That is how if and else works. You need to be very careful that at first you need to give first bracket, then you need, here I'm using 2 second bracket. Be careful while writing that. So let's solve a problem by following this particular structure. Here you can see, let's say I have a question here. Check if a number is non-negative or negative. Non-negative means 0 or positive. Negative means less than 0, all the value, right? So let us define a value. Let's say x equal to 5. Just giving a value in a variable. Now I want to check whether 5 is non-negative or negative. And to check that, let us follow the structure if first bracket. Inside the first bracket, you need to give the condition. So the condition is x greater than is equal to 0. So if x greater than is equal to 0, then second bracket. Inside this second bracket, use a statement. That means if this condition is true, print. Okay, print is a built-in function. You already know that. Print is non-negative number, or it is a non-negative number. It is a non-negative number. Okay, that means I am instructing the RStudio that to print this line when this condition is true. But if this is not true, then else, and then give a second bracket. Then click enter and just give another statement. Okay, So the statement is print it is a negative number, right? Negative number. Okay, now let me run this. At first, let me run the number 5, x equal to 5. Now let me run this and let's see what the output is saying. Oh my god, so it's saying it is non-negative number. You can see 5 is not negative, right? Now if I try to use, let's say here, if I use -5 instead of using 5, let's see what the output saying. Okay, you can see that here we got another output and it is saying what? Okay, let me enter that. Let me run that again appropriately. Yes, now it is saying it is a negative number because now this condition is not true. Now some people might be wondering, okay, why if I use another condition, what's wrong with that, like x less than 0? When you are saying else, that means that it understands that is the opposite of the condition you're using inside this if. Okay, inside this if. So you don't need to use any other condition. That RStudio automatically understands that. Okay, now I'm going to show you something really interesting. Okay, instead of using a particular number, you can use another function here just to use any random number you want to enter. Okay, let's say you can check 5, you can check 10, you can check 15, you can check any number you want. So for that, we're going to use another function. Let's say x equal to as dot integer. These options will allow you to write an integer number or any number you want as dot integer, then use read line and give a first bracket and then use prompt. This option, I know there are a lot of options I'm using, but this option will allow you to enter a number. So I'm using enter a number and give a colon and just whatever line you want, you can just use that. Now look at that. If I run this, what happened? You can see that it is saying enter a number in the output screen, not in the input screen. Okay, so in the output, if I enter like 56, then just click enter in the output. Okay, now run the second or run the whole condition if else. You can use Ctrl Z to go back anytime you want. Okay, Ctrl Z. So now it is saying it is a non-negative number. So that is how it works. So here we're done with one example. Now let me show you another example. Check if a number is even or odd. Okay, so when a number is even, so at first let me use this line to enter any random number you want. Okay, so let me copy that and then use the condition if x %2 is equal to 0. Here you must use double equal. Okay, double equal whenever you want to click equal to in a logical way. Okay, so now also for the %, I have to remember I described that this is a remainder operator. This symbol will help you to get the remainder. So it means that if x divided by 2, the remainder has to be equal to 0, because we know that this is the definition of even number. Okay, so it means that second bracket print, it means that the output will be coming out like it is even number. Okay, it is even. Else, then use another condition, else, that means otherwise print, that means when the first condition is not true, it will print it is odd. Okay, that is how you can simply use this. Now if I run the first line, make sure you first enter a number here. Don't run the second line without entering a number here in your output screen. Okay, so I'm entering a number, let's say 33. Okay, and then click enter. Now use this if else condition to check the output. So now it is saying 33 is an odd number. Okay, so that was another example. I hope this idea is very clear to you. I know this is quite simple example. In practical sense, you may need to deal with better and like much more advanced example. So maybe for that we may create another videos like this video is for simple basic. Okay, now another structure can come out, like we discussed about if else, but it is also possible you can use several conditions. For that you need to use if, else if, as much as you want, and at the last you can also use else. Okay, so let me show you how can you do that. So let's say if I use the check if a number is positive or negative. Okay, so at first use if, okay, and call the first line again to enter any random number you want, and then paste it, and then if, and use the first condition, let's say x greater than 0. When x greater than 0, print it is positive. Okay, it is positive. And now let's say I'm going to use second condition, that is when the first condition is not true, else if second bracket, and then print when the second condition is true, not true, then you can simply use like here you have three cases, like a number is positive or negative. Okay, so the three cases, like here I am using x greater than 0 is positive, so then you can use, okay, else if, and you can see that else if, inside the else if you can use another condition. Okay, it's not like that you just leave it out like what you did for else. Okay, so enter a condition here, else if first bracket x less than 0, and then you can just click print. You can just click print here, and inside the print use it is negative, right? So we are done with two conditions. Now another condition here can come out. That is why I'm showing this example. Okay, like else print, another condition is that it can be is equal to 0, right? Then the computer or the RStudio will say it is 0. Okay, so that is the whole idea. You need to use else after the second bracket. Now if I run this, let me just copy that again, not here. Let me copy or cut the x equal to x dot integer, which will allow us to enter a number. So let us enter a number. Let's say the number is 0. Let's see what happens. Okay, I'm not entering any positive or negative, I'm simply entering 0. Now if I run this, let's see what happens. If I run the whole if else, it is saying it is 0. Okay, so that is how three condition can work. Okay, so the last condition meaning is that when both the first and second conditions are not true. Okay, that's the idea of if, else if, and using several conditions. Let us try to run that again. Let's say I'm entering another number. Okay, let me copy that again where it's gone, or just run that directly and enter a number, let's say 54. Okay, now if I run this, if I run the condition here, it is saying it is positive. Okay, make sure before this if else if, make sure you use this line. Okay, make sure you use this line. So that's the whole idea of using condition in R programming. I hope the idea is quite clear to you. At many cases you may need to use that, and also you can see that we learned a little bit more about operator. We have remainder operator, we learned equal to operator, we also learned greater than operator and greater than equal operator. So yeah, that is how you can practice and learn more and more things. Now we are going to discuss the most important topic of any programming languages, is to use the loop. Okay, loop is a powerful concept of any programming language which allow us to repeat any command or a statement at any number of times we want. Okay, it allows us and it gives us the instructions in that way that you can repeat things and can get the output. Okay, so how for that you'll mostly commonly use two loop like for loop and while loop. Okay, and here we are going to discuss both the structure, but we'll solve several problems by using for loop. While loop has in terms of the structure there is a little bit difference, but the idea is almost similar. Okay, in some cases it may be useful, but here we are going to show several problems only using for loop. Okay, so how for loop structure looks like. Okay, the structure simply looks like is that you can use the for. Inside this for you can use like I in some vector or sequence. That means I is a vector or sequence that will tell us how many times you are going to repeat your process or your instruction or the statement or the expression you're using in the body part. Okay, so this part is like the body part. Okay, so to do that, let us solve a problem and understand the structure much more clearly. Let's say the question is that let us repeat a numeric vector for 1000 times. Okay, so let us create a numeric vector at first. To repeat that, you can use any numeric vector you want. Let's say I'm creating x equal to 1:5. Okay, x equal to 1:5. That's the first line I have. And let's say I'm using the for structure for I in 1:1000. It means that I'm using a sequence here. Okay, you can use the vector sign also. So it means that I will be repeated, or I, it means 1 to 1000. It means that when I indicate this task, whatever the task you are giving them, this task will be repeated for 1000 times. Okay, now what the task is, to use the task or main body part or the instruction or the expression part, give a second bracket. Inside the second bracket, use instruction like if I say print of x, it means that I'm telling that print x for 1000 times. Okay, let me run this and let's see what happened. Okay, just run this. So here you can see that 1 2 3 4 5, you are getting this expression or this variable 1 2 5, you're getting for 1000 times. Okay, not more than 1000 times. You'll get that exactly 1 to 1000 times. Okay, so let me use that for 10 times only to show that very exactly. So I'm using I in 1:10. It means I'm saying to repeat that for 1 to 10 times. Now if I run this, you can see that you're getting that only 10 times. Okay, so that is how simply the loop idea works. Okay, and now let's do another problem. Let us repeat a character vector for 100 times. Okay, let's say I'm using character. Let's say the character vector is y is equal to c. Anything you can write. Let's say a, b, and comma, and c. Okay, so I'm using this character vector and just use for loop, and inside this first bracket use I in 1:100. Okay, and then give a second bracket and then print of y. Print of y, that means I am instructing that to print this y variable, which is a character variable, to print this character variable for 100 times. Okay, so now let me run that and let's see what happened. You can see that ABC is coming out for around 100 times. So okay, so I hope the idea is clear on this example also. Now let's do one or two a little bit difficult example. Okay, now let's say the problem is that find the summation of first 5 natural numbers by using for loop. So I'm telling you to find the summation of like 1 2 3 4 5. Find the summation of all this and just tell me the answer. Okay, for these reasons it can be useful if you tell that find the summation of 1000 natural numbers, because it may take a lot of time to calculate, right? But only using 2-3 lines of code you can get the output very easily, right? So let's do that only for the first 5 natural number at first. Okay, and so to do that, at first you are creating a sum variable. Always create a sum variable, because sum is equal to 0. Whenever it is asking to find the summation, always mention a variable that sum is starting from 0. For multiplication, it will start from 1. Okay, this will help us for further instructions. Let me show you how it can help us. Okay, so now you can use the for loop. Let's say for and I in 1:5. Okay, 1:5. It means that I'm telling this to repeat the process for 5 times. Now give a second bracket. Inside the second bracket, use the instruction or the expression. Here I'm using a formula. Sum is equal to sum plus I. Sum is equal to sum plus I. Okay, now why I'm using this formula and how it really works. Okay, so at first I'm telling you that sum is equal to 0, right? And I means 1 2 5 to repeat the process for the 5 times. So at first step, the sum is equal to 0 and I is equal to 1. So what will be the sum? Final sum. Final sum will be 1, right? At second step, the sum will be the final result of the first step. The final result of the first step is 1. Then it will take 1 and I will be 2 because it is second step. Then the result will be 3. And at third step, the sum will be again the result of the second step. So it will be like 3 plus, and the I value will be 3 as it is third step. Then the output will be 6. Now the fourth step, sum plus I. Sum will be the result of the third step. That means 6. And I will be 4. So it is 10. And then 10 plus I will be 5 at fifth step. And the final output will be 15. That is how this formula works, okay? It is taking the sum starting from 0 and always just counting from 1 to 5 and then just finding the summation of every step, okay? So that is how at different step it calculates and give you the final output. So let me run this and let me show you the final output. You can see that the final output, you can just use print sum to get the final output, okay? So I'm using print sum and it is saying 15, okay? So that is how the summation works. Now if you are using 1000, it will still give you the answer, okay? But it will do that for 1000 times, or I cannot just write and show you 1000 times here. It will take a day to do that, okay? So that is how the output is if you find the summation from 1 to 1000. Okay, so now let's do something really interesting. Now let's do the multiplication. Let's do the multiplication. Find the multiplication of first 5 natural number by using for loop. The process is almost very similar, okay? Just here, instead of using plus, you will be using star for multiplication. And another thing is that you must define multiplication is equal to starting from 1. It cannot start from 0, because if it starts from 0, you will always get 0 every time you multiply at every step, right? I hope you can visualize that what I'm saying. So if you fail to visualize that, let me show that. At first, for multiplication, let us create a variable. Multi is equal to 1. It means you are telling the process for 5 times starting from 1, okay? So to do that, to tell that, use the for I in 1 is to 5. Okay, that is what the meaning. That is why I'm just using some note to explain that, so that you can read that also watching the video, and it's maybe easier for explaining. And just give a second bracket and then use multi is equal to multi into I, not summation, right? That's the difference between the last one and this one. Now if I run this, I should get the output as 120. Okay, let me use the first bracket here because here I'm getting a cross sign. Okay, so let me run that, and here I'm getting and then use the print multi. Okay, that means you are asking them to print the multi variable. Now you're getting 120. How it really works? So at first step, it is taking multi starting from 1 and I will be 1, right? So 1 into 1 is equal to 1. Second step, 1 is equal to multi, which is the final output of first step, and I will be 2 at second step. So you are getting 2. And third step, 2 into I value will be 3. That means multi into I, that will be equal to 6. At fourth step, it will take the result of the third step as the value of multi, which is 6. And then the I value will be 4. It will get 24. Then at last 24 into 5. And it will be like 120. Oh, so that is the whole idea of for loop. We used several examples. I hope that you can now practice different examples by taking from internet or can solve. Just try to solve as many exercises as you can. Once you are comfortable using this loop, it will be easier for you to use R programming, okay? So now how the idea of while loop really works. There is a small difference in terms of the structure. At while loop, you must use the condition inside the while loop. You can see that for using for loop, I just mentioned that how many times it will repeat. Here, you don't use that directly here. You just use that as a condition, then use the statement or expression. But before using while loop, you must mention that from where you want to start your loop, okay? So let me show that by using exercise. Let's say that you want to repeat a vector for 10 times. Let's say I'm creating a vector which is equal to x equal to 1 is to 5. Okay, and then mention where the loop or repeating variable will start. You must do that in while loop. So let's say I is equal to 1, I is equal to 1, right? And then mention the condition of the repeating variable. Okay, so I'm using the while I mentioned that I is starting from 1. Now I have to mention that I less than equal to 10. It means that it's starting from 1 ending with 10. Just I'm showing that in a condition way instead of saying that directly, which I did for loop, right? So now just give a second bracket and use the expression like print of x. But now here you also need to mention another thing which I didn't do for R. You need to mention I is equal to I plus 1. Okay, I is equal to I plus 1. That means I is starting from 1 and every step it is increasing at 1 by 1. Like at first step it will be like 1, second step it will be like 2. So that is how it is increasing. That is how I am giving the instructions, okay, that repeat the process for the 10 times. Okay, so now if I run this, if I run the whole example here, now you can see that 1, 2, 3, 4, 5, it is repeating for 10 times because I am giving the instruction to print the x variable. Okay, that's what my objective here. And for that I am using loop, condition, and giving the formula again how to repeat the loop. So yeah, that is how the whole idea of for and while loop. Okay, so now we are going to discuss another topic named as function. So function is important because, you know, I already described that in our packages there are a lot of built-in functions, and to create your own packages, to create your own function, you must learn these ideas very well. For example, some people here may be watching this video who are from genetics background, someone from, you know, like maybe social background, some people maybe from business background. So you have different data set. For that reasons, maybe you need to fit a new model. Okay, so whenever you want to fit a new model, for that reasons maybe you need to create your own package or own functionality. Okay, so let's describe the idea of function. Let's describe very simple way at first. What is function? Function shows the relationship between variables, where you can find the value of one variable by using the value of another variable. So it's like you are giving input of one value as of one variable and you're getting output as a value of another variable. For example, you can see here we have function named as like f of x equal to x whole square. Okay, so whenever you're inputting the x value is 1, you are getting output as 1. When the input is 2, you are getting output as 4, right? So consider here f of x is equal to y. Let's say the function is y is equal to x square. So it's like the relationship between the variables between x and y. Okay, and you are giving the value of x as an input. On the other hand, you are getting the value of y as a output. So that is how functionality really works. And yeah, there are a lot of built-in function in R. I already described some of those like length, mean, median, mode. You can just simply call the function name or call the packages where those functionality exist, which are not exactly built-in function directly. Okay, so in function in R will allow you to create a set of instructions so that you can perform different operations. Okay, and the common structure of function in R looks like this. Like at first you need to include function name, then function argument body, and again you need to call the function name. So let us describe that a little bit more on the R Studio. Okay, so here you have the basic structure of the function. As I said already, at first mention the function name. So what is function name? Function name contains the name of the function, okay, by which you can call the function at your output or to get your output. Okay, so you can give any function name you want. Okay, make sure there are no space between while giving the function name. And then equal to function. Here the argument options will allow you to add the variable, one or more variable, or you can call it like one or more parameter, so that you can add the instructions in the function body by using those variable. Okay, let's say your variable is x, y. So just mention here x and y. And then give a second bracket. Inside the second bracket, the important one is the function body. Function body contains all the formulas or the statement or any kind of instructions you have. Okay, depends on what type of instructions you have. Okay, and then the return value. The return value, you can get the output here. I just mentioned it directly, that just directly call the function name and use any kind of value you want. Just give a value as input. Okay, the value of the variable or the argument you have. Okay, so if it sounds a little bit confusing, don't worry, let's show that with some examples and let's make it very clear. Here, let's say I'm asking you to create a function of f of x is equal to whole square. Okay, and let's say that we are going to follow the structure. So at first, give a function name. Let's say the name of the function is if. You can give any name you want. If is equal to function and bracket. And in this bracket, I repeat, you need to mention the variable name as your argument. So in this function, you have the variable only x, okay? Because here f of x means actually the output. You can consider it y if you wish, okay? So here I'm considering directly f of x. So you can just call x only, okay? Then give a second bracket. Inside the second bracket, you need to mention the function body. That means the formula or the instruction you have. So what type of instruction do you have? Your instruction is that give me the square of the variable. Give me the square, that means x square. That's the only instruction you have. So you are done with creating your function. Now to get your output, you need to call the function and give an input. Okay, so let's say if is the name of the function and give an input. Let's say the input is 5. Okay, that means I'm giving the value of x. I repeat, this is the value of the argument you define. Here, if you have x comma y, then you need to mention two value. Okay, so now if I run this function, you can see that I'm getting the output 25. That means that I'm giving the instruction x whole square. So you're getting the output as 5 whole square. That means 25. Okay, now if we use if 6, what will you get? If you just run this, you'll get 6 whole square, which means 36. Okay, and then let us try to create another function. This is going to be much more interesting because here you have like 3 variables. The function is f of x is equal to x whole square plus y whole square plus z whole square. Okay, so here you have 3 variables instead of only one variable that you had previously. Okay, now let's give another name. Let's say Rohim is the name. Rohim is equal to function and let me fix my keyboard. Yeah, it's working. So function and then a first bracket. Now in the first bracket, you need to mention the argument you have. So here the argument you have x comma y comma z, right? And then give a second bracket. Inside the second bracket, mention the instruction. That means I want this instruction x whole square plus y whole square plus z whole square. So just use x whole square plus y whole square plus z whole square. Okay, now at last call the function name and give an input to get or to have your output. So let's say the input is for x it is 4, for y it is 2, for z it is 5. You can give any value as input you want, but here I am using 3 value because you can see that Rohim xyz was the argument value xyz. So you need to mention all the argument, right? That is why I'm giving 3 value here. Okay, now if I run this, I will get 4 square plus 2 square plus 5 square, which means 45. Okay, so I hope this idea is also clear to you. Now let's do one more example. Okay, let's do one more example. Create a function to find the power of any value. I want the power of any value, which is a little bit similar but it's gonna be interesting. Now you need to understand what kind of instructions you may have. Like at previously, I'm just directly having the formula and use this formula as my instructions. So to have the power, let's say the name of the function is power, POWR. I'm only using a shortcut. Okay, you can give any name you want. Then function function, and first bracket, let's say I'm considering two parameter, two argument, or two variable x comma y, and then second bracket. Now let's say if I give the instruction as x to the power y, x to the power y, that means I want the power of x and y is the upper value, right? Now if I just call this power 4 comma 5, it means 4 to the power 5. So 5 is for y, 5 is for y, and x is the main one, right? Now if I round this, I will get 4 to the power 5, 1024. Now if I use power, that means I call the function name and the argument value for x, let's say 2, for y, let's say 3. Now 2 cube, here I want 2 cube. So 2 cube should be equal to 8, right? So that is what the examples of function. Now something much more interesting, okay? I already described that there are a lot of built-in function in R. Let's say I create a variable for x, and let's say I want to find the mean, and there is a built-in function named as mean of x, okay? Now if I call the x means here the variable, in fact, like built-in function means the mean only, okay? So if I call the variable inside the mean function, I am getting the mean here. So I hope you know how to find the mean. Mean means like summation of these three, summation of these 6 number, like 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6. That is what the formula of mean, like summation of all numbers divided by the number of observation. Well, that is how the mean function works. Now let's say I'm telling you to create a function to find the mean, okay? So this is gonna be really interesting, okay? So for do that, let's say the name of the function is mean masterclass, okay? The name of the class is mean masterclass, okay, is equal to function. Now what kind of parameter you want? Let's say I'm using only x right now, and then give a second bracket. The formula is that sum of x divided by the number of observation. That means to have the number of observations, that means like here we have 6 number of observation. To have the number of observation, you need to use another variable. Let's say this is n, okay? But remember that here I didn't define in n here directly. If you want, you can define that, but it's much more smart way. If what you can do, you can just mention here what is n inside this function, okay? That means let's say n is equal to length of y, okay? So n means length of y. That is how I can define that instead of defining it here directly. Because if I define x comma n, then in the output, you know, I should also know the value of n. Okay, whenever you have a big data set, okay, it's okay if you don't know the value of n. Okay, now let's call the function name mean master class, first bracket, and then the value of y, let's say here the value of x. You can define any vector you want as a value of x, like 1, 2, 3, 4, 5, 6, okay? So I'm using a vector because I don't just want only 1 or 2 value. Okay, now if I run this, you can see I'm getting 7. That means there is something wrong in the formula or the function I use, okay? So to find out what's wrong, let us try to like here the name is the mean master class, and then I use function of x, then I use n is equal to length of x, then I use sum of x. I'm sorry, here by mistake I use y instead of x, okay? So make sure you find out your mistakes whenever you made a mistakes, okay? So now if I run this, you can see I'm getting 3.5. okay, what should I get? If I use 1, 2, 3, 4, 5 only, I should get 3. Yeah, 1, 2, 3, 4, 5, 6. I will get 6. So that was right what I get initially, okay? Now you can also use any more value you want, as much as you want, okay? Now if I run this, I will get the mean of these all values, okay? So that is how you can create your own function and like use that in your analysis you want. So yeah, I hope that this idea is very clear to you, and this is a really long video, okay? I hope you watched all the videos and practice by yourself. And if you like the video, please share to this video with the friends or family members who are interested to learn. And Thank you very much for watching the whole video. And yeah, as you know that in our platform, our objective is to provide online courses and live training that I mentioned before starting of this video. So please visit www.datasciencearea.com and also in our Facebook page, LinkedIn, and other social platforms. So yeah, thank you very much. See you on another day. Tada, goodbye.